Hey everyone, in this video we are going to understand what is disk scheduling and what are the different types of disk scheduling algorithms. Okay, and we will also understand what is actual need of the disk scheduling and the disk scheduling algorithms. Okay, so before this, let me tell you that I have made a full playlist of the operating system. You can find it on my channel, and along with that you can find the other playlist of the various other computer science topics. You can find it on my channel. Okay, so do watch them. So let's start our topic, that is disk scheduling and the algorithms. So just to recall, we have already discussed in our previous video how the structure of the hard disk look like. So structure of hard disk look like this. We have various platers. Okay, these are the disk which can be called as the platers. Each plater has two surface, up, down, up, down, up, down. Okay, and the plater is subdivided into tracks. Okay, the concentric circles are called tracks. Okay, and each track is further subdivided into sectors, and other name of the sector is blocks. Okay, so these are the small blocks, right? And if you like collectively take the different you can say tracks on each of the plater, okay, or you can say if you like collect, or if you say this is the track number, let's say X, this is the X track of the next plater, this is the X track of next plater, and if you draw these lines, then this collection of the tracks will be called as cylinder. Okay, so if you just see this diagram, okay, here you can see this is one plater, this is the next plater. So in this plater we have the different concentric circles which are called as like tracks. Okay, and each track can be further subdivided into this small sector. So the numbering starts from the outer position. Okay, so this is the like cylinder number 0. Okay, or you can say this is also cylinder number 0. This is the cylinder number 1. Okay, cylinder number 1. This is cylinder number 2. Okay, so the numbering starts from here, and you can say this is, let's say, plater number 0, this is the plater number 1, and so on. Okay, so I'll show the whole this hard disk with this simple diagram. Okay, this simple diagram which is known as hard disk. Okay, I'll not make this again and again. Okay, and you know that hard disk has a controller. So what is the function of this controller? So controller basically will take the request from the external sources. Okay, let's say some request from the operating system comes, so it will go to the controller, this circuit board. Okay, so you can say each input and output device has some controllers associated with them. Let's say keyboard has keyboard controller, printer has their own controller. Okay, so it is a simple circuitry which understand the request. Okay, so let's say some read request comes, so read request will be forwarded to this controller, and then controller will instruct this, you can say, ARM assembly and the motor to get the data from the desired sector. Okay, and the same way, if some data has to be written, then also the same thing will happen by the controller. Okay, so let's say after reading some data, okay, after the read write head reads some data, then it will be transferred via the controller. Okay, and it will go to the operating system. Okay, so this is like an interface. Okay, this is the interface between this hard disk and the OS. Okay, so this we have already discussed in our previous video. Now let's say we have different files stored on our hard disk. Okay, let's say file1.txt, vlc.exe, some .c file. Okay, many files and folders, they are all stored on the hard disk, right? Now let's say a user opens a file, it double click a file. Okay, let's say file1.txt is double clicked. Okay, and it has some content. Okay, so when you double click, what happens? So as we have seen in our previous video of the operating system, we saw that when you double click, actually that particular file or folder or that executable file, okay, is loaded inside the main memory. Okay, inside the main memory by the operating system, or you can say by the loader. Okay, and then the CPU read the data or the instruction of that particular you can say process which is stored inside the main memory at particular position. Okay, and we also know that the content of the file is stored in one or more than one blocks or sectors. So actually when you are double clicking, the reading of that file will take place, okay, from one or more sectors, right? So your read write head will actually move to the desired sectors, and then it will read the data, right? So that means a request of opening file1.txt, okay, will come to the hard disk. Okay, so I am depicting the request with the help of R. Okay, so let's say request name is R1. Okay, R1 is like opening this file1.txt from the hard disk, okay, so that it can later be loaded by the operating system on the main memory, right? So this all task is done with the help of controller. Okay, this request will go to the controller, and then controller will read this file1.txt, then it will give to the the OS, and then OS will actually load this file, right? So now let's take a scenario. Let's say this controller is you can say idle, or you can say it actually can complete the request in a very short span of time. Then what will happen? Let's say this request of opening the file file1.txt will come to the hard disk. So R1 request will be fulfilled by the controller in a very short span of time, right? So it will be completed. Now it is over, and let's say the next request of opening some another file, let's say it comes to the hard disk, okay, that is known as R2. So it will also be fulfilled in a very short span of time. So it means the controller is able to complete all the requests in a very short span of time, okay, because it is very fast, let's say, okay. Now request to the hard disk for reading or writing the data can come not only from the user, it can come from the operating system also. So let's say operating system is doing some task, okay, at the background, okay, it is doing some background work, and it wants to read some data, okay, let's say some system files it wants to read from this hard disk, okay. Then also the OS will send a request to the controller, or you can say the hard disk, right? The same way system programs like your compiler, like your linker, okay, when they are doing some work, okay, for example you are compiling a program, okay, let's say you are compiling a .c program. So the linker, or you can say the other program like assembler, they may be like trying to access some files which are stored on the hard disk, okay. So those system program can also place a request to the controller so that they can read, write from or to the hard disk, right? So your request to the hard disk or your controller can come from many places, from the user, from the operating system, from the various system programs. Now let's say if so many requests are coming simultaneously and the disk controller is busy, okay, that means if this disk controller, this hard disk controller is opening this file file1.txt, okay, let's say this request name is R1, and let's say a lot of requests from the operating system, from the system program are also coming, okay. So what will happen? The request R1 will be like getting fulfilled by the controller. That means it will be reading this data or writing this data, okay, from the hard disk. And the same way request R2 came, okay. So R2 will not be able to be fulfilled because R1 is going to be fulfilled, okay, it is on the way, okay. The data of the R1 has not been read or written, right? So R2 came in between, okay. This same time linker also asks some like for opening some file, let's say that request name is R3, opening some file, okay. So these requests will not be fulfilled, okay, because R1 is yet to be fulfilled, okay. The data is being written or read from the hard disk, okay. So in this case what will happen? We cannot ignore this R2 and R3, okay. This R2 and R3 should wait, okay. So actually what will happen? Operating system will actually make a queue, or you can say a request queue, which will store all these requests, okay, all these pending requests which are yet to be fulfilled by this hard disk or your controller. So when the request R1 is is on service, okay, the data of R1 is being read, let's say, so R2 will have to wait in this queue. The same way R3 will wait here, R4 or any other pending request, they will wait in this queue, okay. So this hard disk, or you can say controller, will be having this request queue, okay. It will storing all the pending requests, and let's say after some time the data of R1 from the hard disk has been read, okay. So that R1 data, or you can say the operating system, will take that data of the R1 and it will load that file. Let's say we are opening that file with respect to R1 request. It will be placed somewhere inside the main memory, and later on CPU can access the data of that file or the instructions of that file or the process, right? And after that what will happen? The R2 will be taken up, and then R2 will be fulfilled. After that R3 will be taken up, okay. Then R4 will be taken up, okay. So this way we will schedule these pending requests one by one onto the hard disk, right, by the controller. Controller will actually fetch these requests from this request and it will like service those requests. Okay, so this is called disk scheduling. So basically, disk scheduling is the method of scheduling the IO requests which are arriving for this disk. Okay, so these are the IO requests which are coming for this hard disk, right? So putting this R2, R3, R4 on this hard disk is called as disk scheduling. Okay, so scheduling means we are like saying ki, okay, R2 should come, now R3 should come, now R4 should come. Okay, so this is the process of disk scheduling. Okay, so disk scheduling is somewhat similar to the CPU scheduling. In CPU scheduling, what we have understood? We understood that let's say we have many processes which are present inside your main memory. Okay, and they are actually stored in the ready queue. Okay, so the processes are present inside the main memory, and we have to like put them, or we have to select the processes from this main memory so that they can later be put on the CPU for execution. Okay, so CPU scheduling was like scheduling, or you can say selecting the process from the main memory, right? And we have understood many different algorithms which can do this task, okay, of selecting the processes. Okay, which process should be selected first, right? So this answer was given by the CPU scheduling algorithms, right? The same way we will understand there are many different types of CPU scheduling algorithms which will actually tell that in which order your request from this queue should be forwarded or should be put on your hard disk. Okay, so this is not the case like R2, R3, R4 are here, so first R2 will be taken up, then R3, then R4. So this is like first come first serve, right? In which order they are placed inside the queue, in the same order you should take those requests and you should take to the hard disk. Okay, so this is actually you can say one way of scheduling the request on the hard disk. This is like first come first serve. Okay, but there are many other types of disk scheduling algorithms also. And why we are having different type of disk scheduling algorithm? This is the same question that we can ask in the CPU scheduling algorithms also. Like why we are having the different type of CPU scheduling algorithm? We can just say, okay, P1 came first, so P1 should be put on the CPU first. Then P2 came, so P2 should be put. Okay, then P3. In the order in which they arrive inside the ready queue, they should be forwarded to the CPU in the same order. Okay, so then also we understood many different type of CPU scheduling algorithm. Why? Because the order in which these processes should be selected, it can actually determine the utilization of the CPU. Okay, we understood that maybe this P1 is very long process. Okay, P2 is very short process, P3 can be like very short process. So then we understood that SJF can be like a better candidate. Okay, this type of algorithm can be a better candidate. Then we also understood that let's say if each process have their some priority, let's say some process is of higher priority, then out of these higher priority process should be selected first. Okay, because there are various criteria of selecting the processes. In the same way, we can schedule the processes in the different order other than the first come first serve basis. Okay, so basically, as we know, operating system is actually responsible for using the hardware, right? Operating system is actually the interface between the user and the hardware, and the role of the operating system is that it should use the hardware in an efficient manner. If we are talking about the hard disk, then this means that data from the hard disk should be like transferred back to the operating system, okay, in a very fast manner. That means let's say at t equal to 1 p.m. okay, this R2 request came, then in very short span of time the data should be read or written from the hard disk and it should be transferred back to the OS. Okay, and you can say the bandwidth of the disk should be higher. Okay, we want these things should be on the priority basis. Priority basis means we want to have the fast access time and we want good bandwidth. So what is access time? So when a request came and after how much time that request is fulfilled, after how much time the actual data is actually transferred back to the you can say operating system. So that will give us the total access time. Okay, so access time will actually consist of the seek time, rotational delay and other overhead. So we understood in the previous video, let's say your read write head is currently at on this cylinder number 0 and your data is currently, let's say that you want to read is placed here. Okay, that is this is cylinder 0, 1, 2 and let's say this is the 5th sector on the cylinder number 2. So how this data will be read? So first your read-write head will come to the track 1, track 2. Finally, it will come to the track 2 because this contains your desired data. So in how much time it is coming from a particular track to the desired track, that time is actually the seek time. And after that, this sector will come under read-write head. So this head will come here, okay, and this sector will take some time to come under this read-write head. So that time was rotational delay or rotational latency, right? So after that, your actual data will be transferred after reading it, right? So in both of these time, your seek time is actually greater than your rotational delay or rotational latency. That means the time a read-write head takes to come to the desired track from a particular track, that time is actually very much greater than the rotational latency. So if you want to decrease the access time of this particular data, then that means we have to reduce this seek time. Okay, we have to minimize this seek time. So this is the overall goal of the various disk scheduling algorithm, that they want to minimize the seek time. Okay, they want to fulfill the request or select the request from the request queue in such a manner that your seek time should be minimized. And lastly, just for recall, what is the bandwidth? So disk bandwidth means total byte transferred in particular time. So that means, let's say your bandwidth can be like 100 MB per second. Okay, so in this way your disk bandwidth is given. For example, in 1 second your 100 MB is going to be transferred. Okay, something like that. Okay, this we have already discussed disk bandwidth and access time in detail in the previous video. Okay, so we want actually that in particular time more data should be transferred. So let's say if hard disk has like 1000 MB per second, this is the disk bandwidth, and that means in 1 second more data can be transferred by this second type of hard disk. Okay, so the disk bandwidth should also be more, right? So that bandwidth also actually depends that your access time should be like smaller. Okay, for this seek time should be minimized. So we will see when we will solve the numerical that different disk scheduling algorithm will be actually used for selecting these requests in that manner, so that your seek time, okay, this seek time should be minimized. Okay, so that it takes a very less time to fulfill the all the requests. Okay, so these are the different type of disk scheduling algorithms. So we have the first come first serve algorithm, we have the shortest seek time first, scan algorithm, CSCAN, C stand for circular, okay, and look algorithm, and again we have the CLOOK, that is circular look algorithm. Okay, so these 6 different types of disk scheduling algorithm we are going to understand with the help of the numericals in the next video. Okay, so this algorithm will be employed here to select the request so that it can be forwarded to the disk controller. Okay, so disk controller will actually be selecting the these requests. Okay, now before ending this video, let's understand what will be the format of this input output request which we are having here. So basically the format of IO request will be like you will be given platter number, then surface number, then cylinder number, then sector number. Okay, so let's say the request come and this is the platter number 0, this is platter number 1, this is platter number 2. So let's say request will come, for example, the operating system says, okay, I want to read the data from the, let's say, first platter, that is this platter. Okay, and I want to read the data from the upper surface. So let's say upper surface number is 0 and lower is 1. The same way for 0th platter, the upper surface is 0th and this down surface will be 1. Okay, so surface number is 0. Okay, so platter number 1, surface number 0, and let's say the data has to be read from, let's say there is another you can say track. Okay, this is the another track. So outer track is let's say second track, this is the first track. Okay, so we want to read, let's say, data from the let's say this you can say first track. Okay, first track, and then we will be telling, okay, tell me the sector number. Okay, on the first you can say track, from which sector you want to read. Let's say we want to read from here, let's say this is the like 9th track. Okay, so I'll say 9th. Okay, sorry, 9th sector. Okay, so cylinder and the track, they are actually the, like you can say, analogous. Okay, they are like similar. Okay, so I want to read the data from the first platter, surface 0, then I will go to the track number 1 and on track 1 I'll go to the 9th sector. Okay, and whatever data you want to read or write, that will also come, and how many bytes you want to read, okay, that will also come as a part of the request. Okay, so the another type of request can be like, I want to read the data, let's say from, this is the like second you can say track, this is the first track. Okay, and I want to read the data from, let's say, here. Okay, so the another request can be like second platter, surface number, let's say 0. Okay, or the next bit track number 2, and let's say this sector is like 5th sector, so 5th sector. Okay, so this way we will be able to come to the desired sector, right? So this R2, okay, R2 can be like this request, R3 can be like this request. Okay, so it will give the actual address of the particular sector. Okay, out of various platter, how I can come to the desired sector, okay, which are placed on the various platters. Okay, now when we will solve the numerical, now we will not actually take this complete request in this fashion. Okay, we will actually take only the cylinder number. Okay, so here in the request queue only cylinder number will be stored. For example, this one will be stored. Okay, I want to read the data from the first cylinder. Okay, R3 can say I want to read the data from the second cylinder. R4 can say that it want to read from, let's say, 89th cylinder. Okay, or 89th track. R5 can be a request which say, let's say, I want to read the data from the, let's say, 10th cylinder. Okay, in this way. Okay, so your cylinder number will be coming inside your request queue. Okay, and your different type of algorithm that we have seen, FCFS, SSTF, CLOOK, okay, all the other algorithm will be selecting which cylinder request should be fulfilled first. Okay, some algorithm can say, okay, I will do shortest shortest type of work. Okay, I'll first pick that particular you can say cylinder which is like nearer to the read write head. Okay, so in this way there are different type of criteria. We will see like how this different type of algorithm actually works, and the main goal of everything is we have to minimize the seek time. Okay, so lastly, how your disk scheduling numericals will be asked. So it is simple, as we have seen, request queue will be given having various cylinder numbers, and it will be told that what is the current position or the initial position of the read write head. So let's say you are told that your currently read write head is on the first cylinder, let's say this cylinder. Okay, all the read write head, okay, they are on the first cylinder. Okay, and you want to complete the request which are placed on these different cylinders. Okay, so you have to tell that how many times your read write head will have to move, okay, to complete all these requests inside the, you can say, request queue. Okay, so total those seeks means you have to see inside which track I have to move, inside which track I have to move, how many times this movement of the read write head will take place. Okay, so I hope you have understood what is disk scheduling and why do we need different type of disk scheduling algorithms actually. Okay, so see you in the next video, and we will see the first algorithm, that is the FCFS disk scheduling algorithm, and we will see this with the help of example. So please like and share this video and subscribe to the channel and press the bell icon for the notification of the videos. See you in the next video. Till then, goodbye.